Hello everyone, good evening. A very warm welcome to everyone present over here. Myself, this is Priyanka, a team member at Hack the Mountains. So, Hack the Mountains is back with another module of HTM Qubits. HTM Qubits is a quantum of workshops packed together. This is the fifth session of HTM Qubits, and we have loved the support we have reached till now and expect the same in the future. So, in this session, we are going to learn about Python with space applications. For this, we have our speaker, Soutik Nandy. He is the Chief Operating Officer at spaceonova and also a Python with space applications trainer. His very experience in this field makes him the best mentor anyone could have on Python with space applications. So, hence giving a new use to the traditional Python. So, hope all the audience here are those intrigued by the very topic of this session. So, without delaying anymore and to make the most out of this session, let's welcome our speaker, Soutik Nandy. Hi, sir. It is a great honor to have such an esteemed speaker like you with us. Over to you, sir. The
Okay,
stage
hi
is all
Priyanka.
yours now.
Okay, so thank you, Priyanka. Thank you for the introduction. And thank you, Hacker Mountains, and thank you to all our viewers right now who are watching this live stream or maybe a later stream. So, thank you everyone for watching this session. So, without any further delay, let's proceed. Okay, so let's proceed with today's session and let's see what is in store for you all. So when it comes to through Python to the stars, or maybe when it comes to Python, I get a lot of questions. Okay, and the very first question which I get is why do we use Python, or why do we need to use Python? Why cannot I use maybe something else? Why cannot I use C, C++, Java? Why cannot I use all of them? And why are you so fixated on Python? And why are you saying that Python is so good? So you know what? Let me show you C++ and Java and then Python. Okay. So in the very beginning, I'll just open up my Visual Studio Code, and this is for those of you who know what C++ is. It is just a simple program to print one statement on the screen saying "Hello World." So to do that in C++, it takes about maybe 6 to 7 lines at the max, right? So in these 6 to 7 lines, you'd get "Hello World" on the screen. Let's see the same thing in Java. In Java, I think it hardly takes maybe 3 or 4 lines to do the same thing in Java. Well, C++ and Java both are doing a tremendous job. But let's see the same thing in Python. So I'll just move over to my Python notebook, and over here you can see that I need to print this hello world on the screen. And that's it. That's it. It's just one single line to print hello world. And the same thing when I did in C++ or in Java, it took 3 lines, 7 lines, maybe 8 lines. And this Python reduce my typing speed, or it reduces my typing time. Okay, it reduces it. Instead of writing 6, 7, 8 lines, I wrote one single line to do this. Now assume complex program to do so many things, and Python would do the same thing in hardly 3 to 4 lines. We'll see about that. And to do the same thing and to achieve the same thing in C++, it takes lots and lots of lines to do the same thing in C++. So now this question has been answered, that why do we use Python and why Python is so better as it reduces my time of writing. Let us move on to the next question which we get is where can we use Python? Where can we use Python? Now that we have learned that how Python is good, so what are its applications, or in which domain can we use Python? Let me tell you, Python has its application in almost all the fields. As I said, in almost all the fields, they range from space to doctorate to everything. So let me just tweak the question for a bit and change it to where can't we use Python? And let's see what do we get, or where are the exceptions. Well, what are these? These are just braces. What does these braces indicate? They indicate null set or empty set, which means that Python can be used in every in all the domains, in all the fields, Python can be used. Be it anywhere, be it space, be it maybe doctor, be it engineering, be it a commerce student, you all can use Python. Okay, so that is how great Python is. So let me move on to a few applications of Python and let's see where can we use them. Okay, so the very first application you can see is a Discord bot. Okay, and I'm pretty sure you must be interested in the Discord bot and interactive bot where you can find the Discord link on www.spaceonova.com/discord or in the chat section. It is given. So this Discord bot currently reacts to hash slash space slash fr response to hi and at the rate. So you know what? Let me move on to my Discord server. Okay, there is my Discord server, and as you can see that whenever people come in and introduce themselves, this bot greets them instantly by saying, "Hi, hi Subhajit, nice to meet you." It also reacts with the H and I, saying, "Hi, nice to meet you." So if I move on to my other commands, they are slash space. If you write slash space, it returns with a random space back. It says that the International Astronomical Union reclassified Pluto as a dwarf planet in 2006. Well, that is true. And the details is because Pluto does not gravitationally dominate the neighborhood around its orbit. That is something great. Now let's see some other. It is because of the huge tilt, a season of Uranus equivalent to 21 Earth years. Okay, and not only that, it has so many random space packs. And if you go on and search for another command, which is slash fr, it responds with a random comment from Friends, the famous TV show. So this one is, come on, Ross, you're a paleontologist, dig a little deeper. Well, it is said by Joey, where Joey clearly does not understand what a paleontologist means. And again by Joey, how you do it. Okay, I want again it's the same thing, it's random. So this is all a moot point again by Joey. Well, Joey is famous, there is no doubt. Okay, so these are some of the commands I showed you, and there are a lot of things the Spy bot can do, and they are all hidden as your Easter eggs for you to figure out and for you to find them out on the Discord server. So, so now the Discord bot does a tremendous job. There is another bot which is a Telegram bot. Okay, and the syntax or the command for that is slash search, and whatever you search for it returns a picture of the same. Okay, so again, if you want to interact with the bot, you can find the Discord link in the chat section. So I'm just moving on to my Telegram. So if I go ahead and write slash search and want to search anything, maybe nature. If I write slash search nature, it moves on to Unsplash API, collects a picture of that, and sends the same thing on the channel. Well, in the very beginning, it takes a little time, but once it has sent, it is now moving fast. So Unsplash API has a lot of fantastic images where you can see how great this image is. If you want to see something else, maybe mountain. So you know what? Let's search mountain and voila, a wonderful image. If you're a dog lover, search dog. Okay. So in case you want to see pictures of dogs, well, that he is a cute. So not only that, there are a lot of things, and if you search for maybe something else, you made something random. Okay, then the Discord bot or the Telegram bot says no results found. Well, obviously this cannot be found. So obviously search nice things. If you want to see something else, you want to see the moon. So let's see a fantastic image of the moon. And not gonna lie, this is actually a very nice image. And if you search again, okay, if you are searching again for another image, so this returns a randomized image every time. Okay, and as you can see, the image has changed, so you never get a single response or a single image or the same image. You obviously get a different image every time you search for the images. Okay. So this Telegram bot has just one feature, and the rest of them are open to interpretation, open to you all, so that you can find things and we integrate the same in Telegram. bot if you don't mind. So that is one application. And the third application, which is my personal favorite, is Automate Your Life. And I'll attach a hashtag with it, hashtag Automate Your Life. Okay, so the very basic automation we see today is making 1000 folders. Well, what is that? What is the automation? This is very simple. Just we move on to a laptop, right click, new folder, one, done. Right click, new folder, two. Right click, new folder, three. And you have lots of time in the world. And till then, you create 1000 folders. That's it, right? That's it. Just clicking on right click, moving on one, moving on two, moving on 1000. That's it. Just 1000. That's it. Simple. So is this the right way of doing things? No. This is not the nice way of doing things. We want a faster way of doing things. And I'll show you the same using just two lines of code. So the original question I've divided into fragments. So the very first thing what we want to do is making one folder. And to do that, I just assume that, maybe there is a make folder and one, which will create a folder by the name one. Okay. So now make one folder, done. Let's create 1000 folders. Okay. So I'll add a loop over here by saying for I in range 1000 and make folder, I'll change it to I. Okay. So for I in range 1000, make folder of I. That's it. That's it. Just one line. That's it. And a second line. So this is a loop which runs 1000 times, and this creates a folder every time by the name. Maybe one, then two, then three, then until then to 1000. That's it. That's it. So will this run? Well, the answer is no, because what is make folder? Okay, this make folder we have defined. So you know what make folder is. I know what make folder is, but Python doesn't know what make folder is. करेक्ट तुम्हें पता है मेक फोल्डर क्या है मुझे पता है मेक फोल्डर क्या है पाइथन को नहीं पता मेक फोल्डर क्या है well this is a reference from movie Total Dhamal so if you haven't seen Total Dhamal do not see Total Dhamal okay so let's move forward and we'll come to the question of what is make folder so Python comes into picture and says that bro I do not know what is make folder can you write the code for that in Python I'm like nah I cannot it's too tough man I cannot. So Python says that, or Python says, is it available on the internet so that I can download? So I'll bring your attention to this word download. Download also means import, correct? It's import, and the other thing is export. Download also means import. So is Python is asking that is this available on the internet so that I can just simply import and use it? So I'm like, yes, it is available as mkdir. How do I know it's mkdir? Very simple. I just went on the internet, wrote make folder in Python, and it returned me the very first result, mkdir. So I'm like, yeah, it's available as a name mkdir. Fantastic. Then Python says that do you know the name of the folder so that I can download? Again, this folder also means okay. Python or Python is basically asking what is the name of the module so that I can download. I'm like, its name is OS. You'll ask me again, so how do you know it's OS? Well, it's very simple. It's given over here. It's os.mkdir, which means that the name of folder or the name of the module is nothing but OS. Its name is OS. So now this was the original code. So I'll add one line over here which says to download OS or import OS. Now that is done. I'll write over here OS dot, okay, to make sure that this make folder is attached to OS. But again, there is no make folder in module OS. We have the name of mkdir. So I'll change that to mkdir, and that's it. This is line number one, line number two, line number three, three lines, and 1000 folder done. You don't believe me? Let's see it in action. So, well, I have my code for the same thing. I have making 1000 folders, and why it's zero because I'm a programmer. I start from zero counting. So, well, you can see that I have this function this basic function. I've also used a lot of things to show how much time does it take. Okay, so these are just funky things. Don't worry about that. And this is the folder right now, which is completely empty. Folder. This folder is empty. So let me just run the code for 1000 folders and let's see what does it happen or how much time does it take. Oh well, it took 2.4 seconds. Not bad. And oh, done. 1000 folders done. So how about I close a few tabs and then let's see how much time does it take again. So let me just delete all of them. It's time. Operator laptop. It's a bit of time. Okay. So as soon as the download is completed, I'll just try to maybe run them again. Okay, I'll run the cells again. This time making sure how much time does it take, or maybe just forget it. It takes a lot of time. So it takes 2 seconds, and if you run this on your laptop, it would take not 2 seconds, but less than 2 seconds. Hardly 1 second it would take to make 1000 folders, or maybe less than that, depending on the whatever your operating system is and the processing power of your laptop. It'll take less than a second, or maybe less than 2 seconds. That's it. My potato laptop takes a lot of time. Your laptop would take very less time. So let's move forward. Okay, wow, this is some wonderful image. Okay, this is a nice image which I can see right in front of me. This is a nice image, and well, it looks like it has been graphically rendered, right? But no, this hasn't been graphically rendered. It has been created via code using Python. Okay, it has been created via code using Python. Well, we extracted the images from the internet and used Python to make it something of this sort, or GIF. Okay, so let's move forward to something which is known as a mass opposition. Now I'm sure all of you or most of you must know what mass opposition is. In case you do not, I'll tell you what mass opposition is. Mass opposition occurs when Earth the Earth, the Mars, and the Sun, all of them are in the same straight line. So if the Earth, the Mars, and the Sun are in the same straight line, that is what is known as the Mars opposition. So that has occurred on the three dates, which is July 27, 2018, October 30, 2020, December 8, 2022. Those are the three dates on which the Mars opposition occurred. So how about I see the same, or I see the solar system on these three dates. So let's see that, and there you go. So this is the solar system on the 27th of July 2018, which you can see is wonderful. This is the Sun, this is Mercury, Venus, Earth, and Mars. You can see the Earth, the Mars, and the Sun are on the same straight line. All three of them are on the same straight line. Not only that, when you move on to 13th of October 2020, again the Sun, the Earth, and the Mars are on the same straight line. Let's move on to the future. Let's see what will happen in 2022. Earth, Sun, Mars again on the same straight line. How great is that? So let's move forward to something which is known as, wait a minute, lovers reunion after 800 years. Okay, what is lovers reunion after 800 years? Which phenomena are we talking about? A lovers reunion after 800 years. Well, this was a recent phenomena which happened after 800 years. It was Jupiter-Saturn conjunction, which you can see right in front of you. The minimum approach which they were at was less than a degree. It was 0 degrees and 0 6 minutes. So that is how close they were on the 21st of this day. And we wanted to see the solar system at that moment. So if you see carefully, there is the Sun, there is our Earth, there is Jupiter, there is Saturn. So if you see carefully, the Sun, the Jupiter and the Saturn are not on the same straight line. Rather, the Earth, the Jupiter, and the Saturn, these three are on the same straight line. Not the Sun, Jupiter, and Saturn, but Earth, Jupiter, and Saturn, because we are from Earth and we are observing Jupiter and Saturn. Right? So, from Earth, they appear as a same straight line. Okay, so that is something great. Let's move forward to our cannonball experiment. So, well, this cannonball experiment, where it looks dangerous but actually is not dangerous, it is a thought experiment by Newton. You assume that, you know what, let's take a volcano and take a cannon and put this cannon on top of the volcano. Then let's give it a very less velocity. So, this ball comes up, lands at position number A. Let's give it a further more velocity. Again, rather than at A, it moves a little farther and then falls at point B, destroying everything like this. But again, thought experiment, remember. So let's give it a further more velocity. So, okay, well, it moved around the Earth, then at B, so again it moved around the Earth, but in a slightly more elliptical orbit. How about I make the velocity even more? Highest velocity and it escapes the gravity of Earth. When it escapes, it moves around the Earth but on a very, 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 very large orbit. And that is what is known as escape velocity. It is 11.2 kilometers per second. So how about I give it not 11.2, maybe 10, 8, or 6. And then let's see what happens over here. So I have given it a 3. So again, crash landing. I give it 8 and whoa, that is great image. You can see when it moves around at 8 kilometers per second. Let's give it a 10 kilometers per second. And whoa, that is a wonderful orbit. If you can see, how about we give it more than 11.2 to give it 12 kilometers per second. And in that case, it moves right out of the Earth and maybe it moves around the Earth but in a very, 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 very large orbit. So I'm pretty sure you all must have known that it escapes the gravitational pull of the Earth for more than 11.2. But this is what happens at 10 and this is what happens at 8, which I'm pretty sure you must not have known because it's something great and you can only see via simulations or maybe sit in a rocket and then move at 8 kilometers per second. So either way, you can do the same. Next, if you move forward to Orion, but in 3D. Okay, well, we all know what Orion is and how beautiful the constellation looks like, and it is known as the Hunter, correct? It is known as the Hunter, called the Hunter. The constellation is known as the Hunter, and it looks wonderful in the night sky. But there's a question that how about we take a rocket, okay, we take a rocket and then move into the space and let's see the Orion but with a closer visibility. Okay, maybe from close if you see the Orion, okay, not from the Earth but into the space and then let's see the Orion. Can we see the Orion? Can we see the Orion but now better? That is the question. So how about I do the simulation for the same thing and then let's see what will happen if you go into space and see what we get. So if we run the simulation, there you go. So those are the three stars. So well, where is my Orion? I can't see Orion. Why cannot I see my Orion? Well, it is because of the location where we are, because of the position of the earth, and because of the curvature of the night sky, because of the distance of earth from all these stars, we can see the Orion like this. If you weren't on Earth, let's say if you were on Mars, maybe you would not have seen this Orion. because these stars are not on a single plane. They are light years apart. You can see this star is light years apart from this star, and this star is light years away from this star. So there is a lot of distance, between the stars, and because of the present location of where we are, you can see this wonderful constellation. So remember, this will never look exactly like Orion, which you see from Earth, because visualization does not curve as the night sky does. There is beauty in understanding the earthly perspective. You see the shape because of the Earth's location in the universe and the location of stars in the constellation. So be grateful that we are on this, or we are blessed to live on the planet. Now, is that ISS? Well, yes, that is ISS. But how about I tell you that you can locate the ISS or see where this ISS is right now. So let's do the same thing. Let's see where this Orion or this ISS is right now. But the longitude is 37 and the latitude is -2. And there you go. Right now it's in Saudi Arabia. And if you move or if you run the cell maybe after 2 3 minutes, then this location would have been somewhere over here. Okay, so let's run the cell and it has slight change. Okay, the location has slightly changed. Not earlier it was here, now it is here, slight changes. But yes, you can see where the ISS is right now using your Python and not using any tools, not using any software, just simple Python, and you can see where the ISS will be. Okay, so let me just run this again and let's see. Okay, where the currently is. No worries. So if you move forward, it's something known as double pendulum. Well, what does double pendulum mean? Does it mean that there are two pendulums side by side? No. It means that there is a pendulum and then you attach another pendulum right below it and then just move them together. So you know what? That's difficult to visualize. So how about I see the visualization right in front of me and there you go. This is one pendulum, this is another pendulum, and this is the pivot point right in the middle. And you can see that how beautiful this looks like. How beautiful is the trajectory, how beautiful are the two pendulums revolving or swinging. You can see, and it's just beautiful. I have looked at it for hours, and I'm sure you also look at it for hours because there is a beauty in this particular simulation. There is a beauty in the simulation which you can see. So just closing the simulation right now. Well, it's beautiful. It's just simply beautiful. So again, not okay. I have said a lot about double pendulum. Let's move forward to some 18 plus content. And well, small kids, close your eyes. This is not for you. Okay, these are only for the grown-ups. And that is nothing but our very famous integration. So if I ask you what is integration of x squared dx, I'm pretty sure this chat session will be spammed with x cubed by 3, and some would say x cubed by 3 plus c. Well, you all are correct. But how about I ask you, what is the integration of tan inverse x by 1 by 1 plus c? Ha, I'm pretty sure that none of you or most of you, it will take a lot of time. It will you have to substitute x is equal to something else and then do something, apply a lot of rules, and then let's do it. So I want to do the same thing using Python. Let's see how we can do the same thing using Python. So I'm writing a single statement. Integrate a tan x by 1 by 1 plus x squared. And then let's see what the answer. Oh wow. It's x tan inverse x minus log of x squared plus 1 by 2 minus 8. Oh, sorry, minus tan inverse x whole square by 2. That's it. If you would have done, it would have taken a long time. So, not that, let's move on to some definite. integral, which is limit 0 to infinity ln x by 1 plus x squared dx. Okay, looks simple, but okay, it again takes a lot of time, a lot of completion to do ln x by 1 plus x squared. You to split it from 0 to 1 and then 1 to infinity and then do your integration. And if you do, I'll just do the same thing using one single statement. And let's see how much time does it take. And done. Okay, done. How much time will it take? Hardly 5 seconds or maybe 3 seconds. And you can see the answer which you are getting is 0. With this definite integral, the answer is 0. That is how simple integration, differentiation, limits, left hand limit, right hand limit, partial differentiation is using Python. Well, SymPy is great when it comes to your integration, differentiation, partial differentiation, limits, and okay, so SymPy, well, that's great. So if we move on to hidden pulsars, which you can see, well, hidden pulsars, it's basically what is a hidden pulsar or what is a pulsar. Well, let's discuss what pulsar is. If you know what a pulsar is, well, you must have known that how beautiful or how majestic this pulsar looks like. Well, it is great. So let me just show you the image of how pulsar looks like. And okay, my bad, someone must have replaced it. This is not the pulsar I'm talking about. This is the pulsar I'm talking about. So this pulsar has your radiations, electromagnetic radiations and magnetic field, which you can see an electric fields, and this is revolving at very high speeds concentrated in a single or very less small ball, and it radiates twin beams of energy from either sides. And when these twin beams of energy are pointing towards us, you can see the pulsar. If it doesn't point towards us, we cannot see the pulsar. This behavior is very similar to that of a lighthouse. When this lighthouse points towards us, we can see the light, and when it doesn't, we cannot see the light. Similarly, this is the case of pulsar. So now you imagine you are in front of the pulsar. Okay, it's similar to that of lighthouse. So if you're in front of the pulsar, clicking pictures, what is the probability that you will capture the pulsar? It's very, very, very low to capture the pulsar because of its speed and because of your limited ability to capture pictures. So a question arises that how can we find pulsar? I have clicked 1000 images. How do I find out where the pulsar is? How do I figure out that there is a pulsar in this image? Well, what we do is we stack those images. We take a software, we take those 1000 images and we stack them together and get a final result. Well, to do that, again, as I said, that it takes a software to do so. Let's do the same thing using Python. If we do the same thing using Python, well, this is a random image I'm showing you. It's a random image, so this is what it looks like. It's completely filled with noise, and I cannot even see the pulsar with my eyes. This is another random image which I have taken again. It's filled with noise, no pulsar whatsoever. So how about I stack them? If I stack them, this is the final image which I am getting. This is the final image which I am getting. As you can see, this cute little pulsar right in the middle. That is what we needed. And because of the intensity is very low and the intensity of noises are very, very high in these two images, our cute little pulsar was lost among them. We could not see, but because of stacking, we could see this cute little pulsar right in front of us. Well, it's actually cute and you can actually do figure out the pulsar. Now, there are a lot of methods to do the same thing. We or to stack the images where we have used the medium because it's proved very effective and it has shown promising results right in front of you. If you would have used mean, you wouldn't have got a nice answer. Okay. So now we have come to the last segment of this webinar, where which is the question of which game it is. Okay, so which game is it? Well, you all must know which famous game I'm talking about. It is nothing but Among Us. It's the very famous Among Us game, which we all have played. If you haven't, I'm not advertising Among Us right now, but you should play Among Us. It's a great game. So, how about I tell you that this picture is again not graphically rendered, whereas it is created by Python. Again, you do not believe me, I'll show you the same thing using my code. So, well, this is my code, and I'll just yeah, so I'll just split my screen into two parts. So this is my code, if you can see very carefully. Yeah, there's my code, and this is my board where I'm about to draw this image, which you are seeing right now. So I'm about to draw them. So let's run the code and let's see. Beautiful. That's it. Done. We have created the same image which you see we have created right in front of you just now. You can change the color, you can change this color, you can add hands, you can add a lot of things and do it and make sure it looks more fantastic. We have used Python Turtle graphics. It's very similar to that of logo or turtle if you have heard about it. It looks very similar to that, and that is how we have created this particular Among Us character. So thank you for your time, everyone, and we have come to the end of the session. So in the end, I'd like to say that see you live and see you alive. Okay, see you live and see you alive. I'm pretty sure you all must be motivated and you want to kickstart your journey, but don't know how to kickstart your journey. Well, Spaceonova brings to you India's first space science challenge in the fields of rocketry and the fields of satellite, where you can go ahead and register for free on ssc.spaceonova.com and figure out what it is. I think you all must know what this constellation is. Well, it's our Ursa Major. Anyway, Big Dipper. So we have this space science challenge or managed by spaceonova.ssc.spaceonova.com. So in case you have any queries and concerns related to space science, you can post them on our Discord forum and we would answer this as soon as possible and engage in the discussion. So stay tuned to us as we create a space ecosystem where limit tends to infinite. So thank you everyone. Thank you everyone for your time and watching this live session.
Yeah, that was a amazing session. Thank you, Soutik Nandy, for taking your time off your busy schedule to be with us here today. That was really great, and it was very amazing to hear out very valuable insights that you gave for us today. And I'm definitely sure that our audience enjoyed and learned something new with this session. And I would like to thank everyone who is a part of this and our success. And I guess there are no questions from the audience. Audience, if you have any, you can post in the comment section so that our speaker can answer them.
Definitely.
Yeah. Okay, I guess there are no questions. Once again, thank you, sir, for being with us.
Thank you.
And before we sign off, I would like to mention that the feedback form link will be shared in the comments so that the audience can fill it to get a participation certificate from the Hack the Mountains. So stay tuned with us for our next session on 4th April and also register for a hackathon and participate in it. I am sure that you will definitely have fun along with knowledge. Yeah. Thank you very much.
Thank you. Best of luck.
Thanks a lot. Bye, guys.